Hello everyone, I am Preetha Datta Chaudhary and my group members consist of Snigdha Sheel, Prerna Garg, Mritika Sarkar and Swapnil Dev. And today we are going to discuss on the topic Spatial Angular Tilt and Acceleration Measurement System. And this is our third year project work and we have effectually worked up on it. This project was personally supervised and guided by our Honorable Professor Dr. Rupam Gupta Roy. And our main objective is to determine the spatial angular tilt and the acceleration of a system, which can be done using Arduino and MPU 6050. So I would like to provide a brief introduction. In the fast-paced world of today, accurate measurement of angular tilt in 3 dimensions is essential for a wide range of applications, from stabilizing robots and drones to enhancing virtual reality. Our research intends to fill this gap by developing a sophisticated and economical system that makes use of the flexibility of Arduino and the power of gyroscopic sensors. We want to provide a trustworthy and precise tilt measuring system that can be easily deployed in numerous real-world circumstances through rigorous gyroscope sensor integration and calibration. With Arduino serving as the system's brain, we are able to not only gather exact tilt data, but also process, display and interact with it in real time.
So now we are going to talk about the components that we have used in our project. At first we have used Arduino Uno R3 model, then we have used MPU 6050 sensor, which has 3-axis accelerometer, 3-axis gyroscope and temperature sensor. Also we have used Vero board and male-to-male jumper wires for doing all the connections. So now we are going to discuss about Arduino Uno. So Arduino Uno is a microcontroller board based on the Atmega 328P. It has 14 digital input-output pins, of which 6 can be used as PWM, that is pulse width modulation outputs, 6 analog pins, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header and a reset button. It contains everything needed to support the microcontroller, so we can simply connect it to a computer with a USB cable or power it with a AC to DC adapter or battery to get started. Also, Arduino Uno has power source pins such as 3 volt or 5 volt VCC pins, then ground pins and 2 additional pins, that is SDA and SCL pin. The SDA pin is used for data exchange between the master and slave device, whereas the SCL pin is used for the synchronous clock between the master and slave device.
The Spatial Angular Tilt Measurement System utilizes the gyroscopic sensors, accelerometer and Arduino to accurately determine the orientation of an object in 3-dimensional space. To measure angular tilt, the gyroscope provides raw angular velocity data along each axis, roll, pitch and yaw. We integrate these velocity values over time to get angular displacement, and accelerometer in the meantime provides the crucial linear acceleration which is required for stable reference for orientation. Now, the data from both gyroscope and accelerometer are combined using sensor fusion algorithms such as Kalman filters, Mahoney filters or Madwick filters. The MPU 6050 combines these data from these two sensors to provide a complete 6 degree of freedom motion tracking solution.
The MPU 6050 is a popular and widely used motion sensor module that combines a gyroscope and an accelerometer in a single package. It is commonly used in applications that require motion sensing and orientation tracking, such as in drones, robotics, and electronic gadgets. The MPU 6050 typically comes in a small module with 8 pins, of which the VCC, ground, SCL and SDA pins are the most important. To use the MPU6050, we typically connect the VCC, ground, ACL and SD pins to our microcontroller. The MPU6050 contains both a gyroscope and an accelerometer, and these sensors play crucial roles in motion sensing and orientation tracking. A gyroscope measures the rate of rotation or angular velocity of an object around its axis. The gyroscope measures how fast the sensor is rotating around each of its three axes X, Y, Z. It does so by detecting the Coriolis effect, which is the deflection of moving objects caused by the rotation of the Earth. The gyroscope provides data in units like degrees per second or radians per second. This data is used to track the change in orientation over time. An accelerometer, on the other hand, measures acceleration in 3 dimensions, typically in terms of gravitational acceleration. When at rest on the Earth's surface, the accelerometer measures 1 g in the upward direction. It can sense deviations from this due to changes in orientation and movement. The MPU6050 combines the data from both the gyroscope and accelerometer to determine the orientation and motion of the sensor. The gyroscope provides accurate angular velocity data, while the accelerometer helps understanding the orientation concerning gravity.
Roll, rotation around front and back axis. Pitch, rotation around side to side axis. And yaw, rotation around the vertical axis.
So now we are going to discuss about the connections between Arduino and MPU6050. So the SDA pin of MPU6050 is connected to the SDA pin of Arduino Uno. The SCL pin of MPU6050 is connected to the SCL pin of Arduino Uno. The ground is also connected to the ground pin of Arduino Uno, and the VCC is connected to the 3-volt VCC of Arduino Uno.
First of all, for the connection and the code part, MPU will be using the I2C connections for the data communication and transferring. So, the ORH library header should be included in the Arduino IDE first. Then, the MPU6050 library will be added to the Arduino IDE. Then, MPU6050 will be used to make an object named MPU, and in the voice setup section we will be beginning the serial communication in 9600 baud rate and the where begin for the communication part, and also the MPU module has to be initialized. And there are ranges for accelerometer as well as for gyroscope. The limits are 2G, that means 2 into 9.81 meter per second square, and plus minus 250 degree per second. And this module is also capable in giving the results in radian. In the void loop section, we will be creating events. These will be the events called from the MPU Arduino module from the object as AX, AY, AZ, GX, GY, GZ. Then MPU get motion function will be used to accumulate the data in the 6 variables. And then we'll be printing the data on the serial monitor sequentially as we need it, and the readings will be taken in every 1000 millisecond, that means 1 second.
With the help of gyroscope sensors, an accelerometer, an Arduino microcontroller, and sensor fusion algorithms, this spatial angular tilt measurement system can precisely identify the angular tilt of an object in 3 dimensions. The gyroscopic sensor is the core of the system, giving real-time data on rotation speed, that is, roll, pitch, and yaw. It outputs raw data and measures angular velocity along each axis. The final rotation speed is calculated in degree per second or radian per second by integrating the data over time. The accelerometer tracks objects' acceleration along 3 axes, that is x, y, and z, due to gravity, acting as a tilt reference. Gyroscope data is then combined with accelerometer data using fusion algorithms like Kalman's filters for stability and accuracy. This fusion mitigates sensor drift and refines measurements. By merging both datasets, the system computes angular displacement, tilt angle, and linear acceleration relative to a reference frame, providing 3D orientation data.
So now by using another Arduino Mega board, we have interfaced our system with MATLAB, and here we are getting real-time graph with respect to the real-time readings that we are getting from our gyroscope and accelerometer. So this part shows the gyroscope readings, whereas this part shows the accelerometer readings.
Now, if you look at the video, in the output section, the acceleration of x-axis shows 9. That means the gravitational acceleration in this position. And if you move again in the other direction, we can see now the z value is 9. Now, if we move this, we can see the 9 value in y, and the rest of the coordinates are near to 0. If we look into the position of the gyroscope, we can find the angle deflection of x-axis, which is roll, y pitch, and z yaw motion. And we can also get the temperature value from this sensor.
So now we are trying to move our system along different axes and record the readings through an Excel sheet. So after plotting the Excel sheet into MATLAB, we get these graphs on MATLAB.
It finds its application in various fields such as aerospace, civil engineering, automotive, navigation systems, marine industry, pipeline monitoring, etc.
So now we are going to discuss about the future prospects of our special angular tilt measurement system. We can also use this system on autonomous vehicles, which can be developed in future to make driverless cars. We can also use this on environmental hazards monitoring system. For example, we can also can track the hazard caused by earthquakes by attaching this system on the buildings by measuring the tilt that caused by the earthquake. We can also use this in healthcare system. If a patient is in paralyzed or semi-paralyzed state, we can detect if there is any movement on their bodies going on. We can also use this in navigation and mapping system, that is by attaching this to an AUV, autonomous underwater vehicle, and we can use to measure the depth underwater.
At last, this is a fascinating project that enables us to measure the tilt or rotation of an object in real time and determine the orientation of an object in 3D space.
So we are ending our video here, and thank you each and everyone for your time.